There is a rule in evolution. If you are going to be the largest land predator on Earth, if you are going to build a body that exceeds 15 meters in length, that approaches 9 tons in weight, that carries a skull longer than a grown man is tall, then you follow the blueprint. Long, powerful hind legs for speed and pursuit. A deep, wide jaw for bone-crushing grip. Dense, robust teeth designed to hold struggling prey. A body plan optimized for land, for open terrain, for the chase, for the kill. Every giant carnivore that ever lived followed this blueprint. Tyrannosaurus rex, Carcharodontosaurus, Giganotosaurus, all of them variations of the same fundamental design, the blueprint that evolution spent 150 million years perfecting. And then there was Spinosaurus. Spinosaurus had short legs, dense bones, the wrong kind of dense, the kind that makes you sink, not run. A jaw that was long and narrow and filled with teeth that couldn't crush anything. And on its back a structure nearly 2 meters tall that no one, in over a century of study, has been able to fully explain. By every rule of evolutionary logic, this animal should not have existed as a predator. It broke the blueprint in every single direction simultaneously. And yet it was the largest carnivorous dinosaur that ever walked this planet. Not second largest, not comparable to the largest, full stop. This is not a story about a monster. This is a story about a mystery, one that has destroyed careers, survived a world war, and still, after more than 100 years of science throwing everything it has at the problem, has not been completely solved. This is the story of Spinosaurus, the predator that shouldn't have existed 95 million years ago. Before we can understand Spinosaurus, we have to understand the world that built it. Because the Kem Kem beds of North Africa, the geological formation that preserved the fossils of Spinosaurus, were not a normal ecosystem. They were not a balanced system of predators and prey in stable equilibrium. They were, according to the scientists who have studied them most closely, the most dangerous place that has ever existed in the 4.5 billion year history of this planet. That is not a marketing phrase. That is the professional assessment of the researchers who spent their careers there. Here is what made it so extraordinary. Every functioning ecosystem in Earth's history has followed the same basic structure, a broad base of herbivores at the bottom, a much smaller number of predators at the top. This is not a choice. It is a mathematical necessity. Predators require prey. The prey must outnumber the predators, or the system collapses. The Kem Kem formation violated this rule completely. Paleontologists excavating the geological layers found carnivore fossils in proportions that made no biological sense. Giant predators, multiple species, all apex level in concentrations that should have been unsustainable. The herbivore fossil record, by contrast, was thin. Scientists named this anomaly Stromer's paradox, after Ernst Stromer, the German paleontologist who first noticed it and spent the rest of his life unable to explain it. In this impossible ecosystem, the water was ruled by Spinosaurus, a 1.5-meter semi-aquatic predator hunting fish the size of dining tables and sharing its rivers with crocodilians exceeding 8 meters in length. On land, Carcharodontosaurus, a 1.2-meter, 8-ton predator with shark-like serrated teeth, was the absolute ruler, capable of slicing dozens of kilograms of flesh from prey weighing tens of tons in a single bite. Between these two giants, a system of ecological niches existed with almost no margin for error. Each predator had carved out its domain with surgical precision. The water, the land, and a boundary between them that shifted with every flood season. This was the world Spinosaurus was born into. Not a world where it could afford to be average. Not a world where being merely dangerous was enough. In the Kem Kem, you were either perfectly adapted or you were food. Spinosaurus chose a third option. It became something that had never existed before and would never exist again. The story of how we came to know Spinosaurus is inseparable from the story of how we almost lost it forever. In 1912, a German aristocrat and paleontologist named Ernst Freiherr Stromer von Reichenbach traveled to Egypt. He was already an experienced field researcher, already respected in the scientific community. But nothing in his career had prepared him for what his team began pulling from the desert rock of the Bahariya Formation. The bones were wrong. Not wrong as in damaged, wrong as in unlike anything catalogued in the scientific record. The vertebral spines alone, the bony projections rising from the backbone, reached heights that Stromer measured in disbelief, then measured again, nearly 2 meters, on a single vertebra. Whatever this animal was, it was enormous in a way that the paleontology of 1912 had no framework to process. Stromer named it Spinosaurus aegyptiacus, the Egyptian spine lizard, and shipped the fossils to the paleontological collection at the Bavarian State Museum in Munich. He published his findings. He continued his research. He spent decades trying to understand what he had found. By the 1930s, as political conditions in Germany darkened, Stromer grew increasingly alarmed about the safety of his collection. He wrote letters. He made formal requests. He argued, repeatedly and urgently, that the fossils needed to be moved to safer storage underground, away from the glass-roofed exhibition halls that sat exposed to the sky. The museum director refused. Each time. There are different accounts of why: bureaucratic inertia, personal animosity towards Stromer, an administrator who did not consider dinosaur bones a wartime priority. Whatever the reason, the fossils stayed where they were. On the night of April 24th, 1944, Allied bombers flew over Munich. The museum took direct hits. By morning, the original Spinosaurus specimen, along with Stromer's other irreplaceable North African fossils, was gone. Not damaged, not fragmentary, gone. Reduced to dust and rubble in the ruins of a burning building. Stromer learned of the destruction through a letter. He had survived the war, but his life's work had not. Think about what that meant for science. The largest carnivorous dinosaur ever discovered had been physically present in the world, bones that could be measured, analyzed, tested for 30 years. And then, in a single night, it ceased to exist as physical evidence. What remained were Stromer's drawings, his measurements, his notes. For the next 50 years, every reconstruction of Spinosaurus, every model, every museum display, every scientific paper was built from those paper records, from a description of something that no longer existed in 3 dimensions. And here is what we only discovered later, after new fossils were finally found. Stromer's reconstruction was wrong. Not slightly off, fundamentally, structurally wrong about what kind of animal Spinosaurus actually was. Which means for 50 years, science was studying a ghost and getting the ghost wrong. In 2014, a paper was published in the journal Science that sent genuine shockwaves through the paleontology community. The lead author was Nizar Ibrahim, a Moroccan-German paleontologist who had been working in the Kem Kem beds of Morocco, the same geological formation where Stromer had worked a century earlier. Ibrahim had assembled a partial skeleton, not complete, but enough. Enough to see what Stromer's original specimen had been hiding, or rather, what had been impossible to know without new physical evidence. And what Ibrahim's team found in those bones overturned nearly everything. The hind legs were short, not proportionally short in the way that T-Rex's arms were short, noticeably, dramatically, functionally short for a theropod of this size. A terrestrial predator, a biped designed to run and pursue, needs long, powerful hind legs. Without them, the running mechanics collapse, the stride length drops. The pursuit speed becomes inadequate for land hunting. Spinosaurus had the wrong legs for land. But that was only the beginning. The bones themselves were dense, solid. Modern crocodilians have unusually dense bones, denser than comparably sized terrestrial animals, because that density helps them control their buoyancy in water. Dense bones sink, and an animal that needs to submerge, to stay underwater without fighting the tendency to float, benefits enormously from that natural ballast. Spinosaurus had crocodilian-level bone density, in a body that weighed potentially 9 tons. And then the jaw. Ibrahim's team compared the skull geometry of Spinosaurus to modern crocodilians, and to the gavial, a specialized fish-eating crocodilian with a long, narrow snout and conical, interlocking teeth designed to grip slippery, struggling fish. The match was striking. Spinosaurus's jaw was not built for crushing. It was not built for holding large, powerful terrestrial prey. It was built for fish, specifically for fish the size of cars, the giant coelacanths and lungfish that swam through the Kem Kem rivers 95 million years ago. And then Ibrahim found something else, something that, when I read it the first time, I had to read again to make sure I had understood it correctly. At the tip of the Spinosaurus snout, there were small pits in the bone. pressure-sensing pits structurally similar to the sensory pits found in modern crocodilians that allow them to detect pressure waves in the water, movement. The ripple of a fish turning 10 meters away in dark water. Spinosaurus may have been able to hunt without seeing its prey. A pressure-sensing system built into the jaw, a biological sonar for detecting underwater movement, in murky river water, at night, without visibility. The largest carnivorous dinosaur ever to exist, hunting by touch and pressure in the dark. If that interpretation is correct, and the debate continues, then we are not talking about a dinosaur. We are talking about something that evolution took down a completely separate road for millions of years and produced something with no real parallel in the fossil record. Not a land predator, not a water predator. Something that existed in the space between those categories and dominated it so completely that it grew to 15 meters in length and 9 tons of weight, doing something no other animal had done before. Let me build Spinosaurus for you. From the ground up. Start with the feet. They were wide and flat, broader than a typical theropod foot, with a padding structure that some researchers have compared to the feet of modern wading birds. Feet designed not for speed on hard ground, but for stability in soft, shifting substrates, riverbank mud, shallow water, the transitional zones where solid ground becomes something less certain. Move up to the legs, short, as we established, dense with muscle, but not structured for long stride running. Biomechanical analyses suggest Spinosaurus on land was slower and less stable than comparably sized terrestrial predators. It walked on 4 limbs at least some of the time, an unusual posture for a theropod with its forelimbs bearing significant weight. The forelimbs themselves were large and powerful, tipped with curved claws that could reach 20 centimeters. These were not vestigial structures like T-Rex's famously tiny arms. They were functional, capable of gripping, of anchoring, of holding prey against the body while the jaw did its work. The torso was deep and wide, the bones dense. An animal carrying this much internal ballast would not move gracefully on land, but in water, that weight becomes control. The ability to maintain depth, to hold position in a current, to press downward instead of being pushed to the surface. The jaw we have already discussed, long, narrow, 1.75 meters of precision fish-catching instrument with conical teeth that interlocked when the mouth was closed, forming a cage from which nothing slippery could escape. And then the sail. The neural spines extending from the vertebrae, some reaching 1.8 meters in height, formed the most visually distinctive structure in the Cretaceous world. What they were for is the question that has never been satisfactorily answered. Thermal regulation, using the sail as a solar panel to warm the blood, or as a radiator to cool it, possible. But semi-aquatic animals typically regulate temperature through water behavior, not surface exposure. Fat storage a hump like a bison's, storing energy reserves for lean periods. Some researchers favor this. It would explain the structural density needed to support that weight. Display a visual signal visible at distance to other Spinosaurus individuals, encoding dominance, health, reproductive availability. The most dramatic interpretation, and in some ways the most unsettling, the idea that this structure existed primarily for communication, for the complex social signaling of an animal we still cannot fully imagine. The honest answer is, we do not know. After more than a century of study, the most visible feature of the most recognizable dinosaur in the Cretaceous fossil record remains genuinely, completely unexplained. That is not a failure of science. That is an accurate reflection of how strange this animal actually was. The Kem Kem river system, 95 million years ago, late afternoon. The water is opaque brown with suspended sediment, deep in the central channel, shallow and warm near the floodplains where ferns grow from the mud and the air smells of decomposing vegetation and standing water. Beneath the surface, 5 meters down in the main channel, something is moving. Not fast, not urgently. The movement is deliberate, sustained, a lateral undulation of a tail that is flattened like a paddle, driving the body forward with each sweep. The legs trail behind, offering some directional control. The forelimbs are tucked partially inward, reducing drag. A 2022 study from the Institute of Paleontology and Geology in Italy analyzed the geometry of the Spinosaurus tail in detail, comparing it to modern aquatic and terrestrial animals, and found that the tail's shape, height, and lateral flattening matched the tail profile of animals that generate forward thrust through undulatory swimming. Not passive drifting, active propulsion. Spinosaurus was a swimmer, not an animal that waded in the shallows. A swimmer using its tail as a propulsive structure to move through deep water the way a crocodile moves, but at a scale no crocodile has ever approached. In the channel ahead, something registers at the pressure sensors embedded in the jaw tips. A ripple pattern, rhythmic, the lateral movement of something large on Copristis, a sawfish relative with a rostrum studded with teeth, reaching lengths of 8 meters, a fish the size of a bus. In the Kem Kem rivers, this was a common prey item. We know because we have found Spinosaurus teeth associated with Onchopristis fossils, physical evidence of the predator-prey relationship embedded in stone. The approach is unhurried. There is no chase strategy here, no flanking, no herding. There is only the pressure wave, the closing distance, and then the jaw. 1.75 meters of interlocking conical teeth, closing around a body that cannot escape, cannot maneuver in the grip of something 9 times its weight. This was not a T-Rex hunt. There was no bone-crushing finale, no dramatic struggle on open ground. This was something older, more patient, more complete. A predator that had merged so thoroughly with its environment that the boundary between the hunter and the river itself was almost impossible to find. Around 93 million years ago, the world began to change. Not suddenly, not dramatically. Climate shifts in deep geological time are measured in centuries and millennia, slow enough that no individual animal experiences the change, only the lineage feels it, across generations. As the world it was built for gradually becomes a different world. The river systems of the Kem Kem began to contract. Sea levels were rising globally, reshaping coastlines and drainage patterns. The vast, warm, interconnected river network that had supported the ecosystem for millions of years began to fragment, shrinking into isolated pools, seasonal floodplains, smaller waterways that could not support the prey density a 9-ton semi-aquatic predator required. Here is the brutal mathematics of extreme specialization. Every adaptation that made Spinosaurus the perfect river predator made it useless outside the river. The dense bones that gave it buoyancy control in water made it slow and awkward on land. The narrow jaw designed for fish was ineffective against terrestrial prey. The short legs that were not a disadvantage in water became a fatal limitation on land. When the rivers shrank, Spinosaurus could not adapt. It could not simply shift to land hunting. Its entire body architecture was wrong for the purpose. It could not migrate to better river systems. The geography was changing faster than a population could relocate. It was too specialized, too perfectly built for one specific world. And when that world contracted, Spinosaurus contracted with it. There was no asteroid, no volcanic event, no catastrophic extinction trigger. The largest carnivorous predator that ever existed died of hunger. In shrinking rivers, in a landscape that was becoming something it had never been designed for, surrounded by the bones of the giant fish that no longer swam in the depth and volume that a 9-ton animal required. The very perfection that had made it the apex of its ecosystem was the mechanism of its extinction. Here is where I have to be honest with you. Everything I have told you in this video is our best current understanding. It is built on Stromer's notes, on Ibrahim's 2014 skeleton, on the 2022 tail study, on dozens of papers analyzing fragments and isolated teeth and associated fossils. And it is still incomplete. We do not have a complete Spinosaurus skeleton. We have never had one. Every reconstruction you have ever seen, every museum model, every film depiction, every scientific diagram is an interpretation built on partial evidence. Educated, rigorously tested, carefully argued interpretation, but interpretation nonetheless. The pressure sensing pits in the jaw, were they truly sensory, or is the structural similarity to crocodilian pressure receptors coincidental? The debate is ongoing. The sail thermal regulation, fat storage or display, no consensus, no definitive answer. One of the most visible features of the most famous Cretaceous predator remains genuinely unexplained after more than a century of study. The behavior, how did it interact with Carcharodontosaurus on the land boundary? Were there territorial confrontations, or was the niche separation so complete that they almost never met? The fossil record cannot tell us, not yet. Somewhere in the Kem Kem formation right now, there may be bones that will answer these questions. Vertebrae still embedded in rock, a jaw fragment with pressure pits intact, A neural spine that finally resolves the sale question. Or there may not be. Some questions about Spinosaurus may be unanswerable not because the science is insufficient, but because the evidence was destroyed in a Munich air raid in 1944, or dissolved in North African heat over 95 million years, or buried too deep for current technology to reach. Stromer found something extraordinary. The war took it. Ibrahim gave it back, partially. And the animal itself still sits somewhere between the categories we use to organize the living world, not fully terrestrial, not fully aquatic, not fully explained. A predator that shouldn't have existed. That existed anyway. That became the largest of its kind that this planet has ever produced, and that we still, after all of it, do not entirely understand. Spinosaurus was found by a man who spent decades trying to protect it. It was destroyed in a night by a war that had no interest in dinosaurs. It was rebuilt from paper records that turned out to be wrong. It was rediscovered by a researcher working in the same desert a century later, finding bones that contradicted nearly everything the paper records had said. And even now, even after all of that, it sits at the edge of our understanding. The largest carnivorous animal that ever walked this planet, and we cannot agree on whether it had a sail or a hump. We cannot fully explain how it moved. We are not certain what it could sense, or how it hunted in the dark. That is not a failure. That is exactly what a creature this strange deserves. A mystery that resists easy answers. A predator that broke the blueprint so completely that the blueprint itself had to be rewritten. Somewhere in the rock layers of the Kem Kem formation, the rest of the story is still waiting. It has been waiting for 95 million years. It can wait a little longer. Which part of the Spinosaurus story surprised you most? The World War II bombing? The 2014 discovery? The sale mystery? Drop it in the comments. I read every one. If this video made you think differently about what a predator can be, share it. Subscribe and turn on notifications. The next one goes somewhere even stranger.